Hi everyone, welcome to this edition of Water Talks. My name is Ryan Brown. I have with me today Bob Dickinson from our support staff. Um, I'm gonna actually go ahead and make you a presenter, Bob, if you want to get the um, presentation up. I did forget to add in some of the intro slides, so I'll just kind of do them off of memory. I know that we've been doing this a while, so hopefully everyone understands the idea of what we're trying to do here. Today we're talking about common problems with modeling in SWM and some ways to maybe mitigate against those problems and how to address different kinds of issues around that, all kind of focusing on the SWM network within the InfoWorks ICM software. If you do have any questions throughout the presentation, please feel free to ask them on your go-to webinar dialog. There is a little question box. We will only see me and Bob will be the only ones that see those. We'll try to get to them in a timely fashion. If we don't get to the questions, then we can certainly follow up with you guys afterwards. And I guess with that, I'll let Bob take it away. He's doing a majority of the presenting here.
Okay, thanks, Ryan.
Sure.
And am I showing my screen yet?
Yeah, you're up.
Okay. So as Ryan says, I'm Bob Dickinson, been with Innovize for 15 years. Now I've been with Autodesk for 1 year. And what we're going to talk about is kind of tools that you can use in the SWM networks of InfoWorks ICM for making your models better. Basically, what I'm showing here is part of the handout, so you can download the handout, and we'll also email them to you later. Okay. And after I get done with these slides, we'll go into the ICM GUI and see how these things actually work in practice. So excited to be here today. I think this is my third or fourth water talk. I know Ryan has done dozens of them, so he's an expert at this. So let's start from the beginning. And as I mentioned, and Ryan mentioned, we're talking about how to make and debug your SWM model using tools inside of the SWM network of InfoWorks ICM. And it's a auspicious day today. It's a 2/22, February 22nd, 2022. So a lot of twos here. And I put in a Mark Twain quote because one of our hash marks or hashtags on LinkedIn is water matters, and I like this Mark Twain one. Everybody likes water. So what we're going to be talking about is water and sanitary systems, water and stormwater systems, and how to model those in a 1D network and use the tools of ICM SWM networks to see those problems. Okay. One of the things I like about the way we've done the SWM networks inside of ICM is that we've really piggybacked the great capabilities of EPA SWM, and the current engine that we use in ICM is or ICM InfoWorks with SWM networks. It's kind of hard to get all the words together, but basically you have 40 years of tools such as grids, maximas, import and export all of your model results and model data, Ruby scripts and SQL, and a lot of different customization of graphs and worst case scenarios. So all of those tools that have really built up over time in InfoWorks CS, InfoWorks WS, and ICM are available to you in the SWM networks of ICM. So what we're trying to do is integrated catchment modeling using the SWM network, which obviously allows us to model sanitary systems, combined systems, stormwater systems. We have groundwater, you have soil, subcatchments, a lot of different process weather processes like evaporation, infiltration, etc., and obviously water quality. Also mentioned that a lot of the actual ICM modeling includes a lot of SWM5 features such as RDII, which a lot of you in North America use, SWM5 build-up wash-off, a lot of SWM5 infiltration like green AMP, and especially the LIDs, low impact development, or SUDs as they're called in the UK. So a lot of those features are the same in SWM5 and ICM. Okay. So when you run the import to model, basically you have two types of networks. You got an InfoWorks network and you have a SWM network. And they're interchangeable. You can import the SWM network from, for example, XP-SWM or InfoSWM or SWM5 or some other model, and then you can convert that to an ICM network. You can take any ICM network and convert it to a SWM5 network inside of ICM. So it gives you a lot of flexibility. Obviously, if there's a feature in ICM that's not in SWM, it doesn't get translated, and so you have to have a workaround. But for going from SWM5 or SWM5 or other for things like InfoSWM to ICM is pretty straightforward because all the features of SWM5 are inside of ICM. Okay. Now, we do have a lot of help for you besides the online help file. There's also, if you register on the support portal and you're an active user or an active InfoCare person using any of our software, you can go to the support portal, and we have various blogs and videos, for example, on ICM, a lot more on ICM, GeoInfo for water, and you basically go to the Innovize website, go to the online support portal. Apologize for my voice here, it's kind of going a little bit there. And inside the support portal, you also have, at the top, we actually have an Exchange GitHub. So you can get some SQLs, and those SQLs are for ICM, but they also apply to the SWM network inside of ICM. So you can do things like doing traces, basically manipulating IDs and doing a lot of other kind of neat things that SQL allows you to do. And if you're a Ruby programmer, there's also some Ruby scripts in there that you can make an RB file and then use that inside of the GUI. All right, so a lot of help besides just sending information or sending a question to support at innovize.com. You can also go to the support portal and get a lot of information there. Okay, so how do we basically show you what's happening in the SWM network using the SWM 5.1.015 engine? Well, obviously you can look at the kind of the traditional or classic SWM 5 network, and our output report file, which tells you, node flooding summary, node surcharge summary, link, etc. But what we do to tie into all the tools of ICM is, when you run the model, it makes a file called IWR file, and that's the same file, a little bit different formatted, obviously, that's used inside of ICM. And in there, it has two types of data. It has all of the subcatchment data, all the node data, all the link data. It has rain gauge data. It has all the 2D information and any other thing that you're modeling in the model. In addition, what it does is it also includes a summary table. So it takes these summary tables from the report file and puts that into the IWR file. So then when you do like a maxima for a SWM network inside of InfoWorks ICM, you basically are reading the numbers off of this report file and getting in there. So when you do something like the SQL or themes or a stats template, you can get a combination of the time series data and the worst case. And so, for example, the worst case report will show you things like the max capacity, the max Q, the max velocity for the links, and things like the hour surcharge, flooding, etc. for the nodes. Okay, And in addition, with the long section plots, you can also mix and match. So you can have a long section plot and show it over time, but you can also have things like the maximum capacity and a maximum flooding volume, et cetera. So kind of a mix and match of things, but you get everything out of the report file you get inside of the IWR file, which then allows you to basically use all the tools of ICM, of the ICM network. Okay, all right. So for example, if you're modeling a sanitary system and you want to know what the worst case scenario is, you can do two different things. You can do the nodes and find out how much head there is, total inflow, or you can find the total amount of flooding. And for conduits, you can find capacity, flow, velocity, et cetera. So when you run the model, you can take a look at this and see what the worst case scenarios are. You can get this in graphs. You can get this in grid in this particular case. You can export any of this to Excel or to a CSV file or to a shape file. So you can use this with ArcMap, for example. So we're trying to allow you to basically use so many different tools to basically give a validation or verification of your model and allow you to essentially mix and match the time series data with the maximum values that come out of the summary tables of SWM5. All right.
To take a break, we did get a question about explaining what SQL is for people who maybe don't know.
Okay, SQL basically, so for example, SQL would be, it's basically, actually I can't remember do you remember what the SQL actually stands for?
I think it's structured query language. It's a type of programming language.
Yeah, I'll show you an example later, but basically you can do things like, you have the network here, you can go in and say, I want to see all of the links with a max capacity greater than 0.75, and it'll show you that on the screen. Basically, it's just like a mini programming language inside of the GUI that it basically queries the input data, the output data, and the summary data so that you can see better what's happening. And the same thing with themes and statistical templates, et cetera. So all of this data basically is basically showing. Oh, I guess I should have turned my chat on. All right. Okay. So all of this is querying the IWR file. So the same data is used in different things. So you can use it in a theme map, a map on the map on the screen. You can do it SQL, which is a sort of mini programming language, or you can do just traditional statistical templates, or just do grids and graphs to see what's happening, or you can look at the actual text file. Right?
And then one more question, I guess, since we're on the worst case grid report, got a question about, is there a difference between grid and networks, or is it just kind of a terminology thing?
Okay.
I guess between.
Yeah, that's a good point. Yeah, it's a little bit confusing. So basically, you have ICM, which is the overall system. So if I go back here a little bit. Okay. You have integrated catchment model, and then inside of that, I took this directly out of the help file. You have two types of networks. You got an InfoWorks network, and then you have a SWM network, which is, again is a SWM5 network. When you look at the data inside a SWM or SWM network or the InfoWorks network, you're looking at the data in a grid. And then when you run the model, you can look at the output in a grid and also in a graph. So it's very grid based, and I'll show you an example later. But the grid is just a way of showing the data inside of the network. So the network is the important thing. The grids show you the data. Hope that's clear. Okay. All right. So for example, so instead of looking at the SWM5 report file, you can do a worst case report, find out, for example, the max capacity for a particular model network. And you can get it, and then you get it output in sort of a grid. You can do anything with the grid. You can filter the grid. You can do a sort or descending. You can show this as a theme on a geoplan. You could basically export any of this to CSV or to other things. But basically, it tells you and gives you a better way of finding out model problems in there. Oh, another nice thing about the SQL especially is that you can combine things. So for example, you can do things like show me all of the links with a max capacity over 0.9, with a certain Q over Q of a certain value, with a certain surcharge level. So you can do multiple facets of the problem or of the model. Okay. So that's the worst case report, etc. All right. Now, this is a little bit different. I'll cover this a little bit in more detail later. But basically, when you have a SWM network, you have these features, and these features are compatible with the InfoWorks network, which you might think more of ICM. So, for example, the rainfall for a SWM network can be used in the InfoWorks network. Same thing for selection lists. Same thing for pollutographs. The inflows, things like the time patterns and pollutographs, anything that you create inside of the SWM network can be used in the ICM. Now, the ICM network has more of these features, and some of those features can't be used in a SWM network, but just because ICM has more features. So, but it's very compatible, and there's a lot of interoperability between all these different features. So once you, for example, if you import a SWM5 model into ICM SWM networks, or see, I said it wrong, InfoWorks SWM network, any of that can be used anywhere else in the model. You can also do things like mix and match using the SQL various parts of the ICM data and the SWM data, which gives you some possibility. Yeah. Okay. Next slide. Okay. Now, when you're in a model, there's also a lot of like the InfoWorks network. You also get tools, which are a good validation manager. So it gives you a validation check and it tells you things. And especially the one at the bottom is something that a lot of people don't really understand what happens with the SWM network, SWM5 engine. The SWM5 engine will actually fix model data errors inside of the engine. So for example, if you have a situation where the crown of the pipe is above the elevation of the node upstream or downstream, it'll actually increase the depth of that upstream and downstream node. And you can see what it's done in the report file, but a lot of people don't look at the top of the report file. So now, at least with the validation manager, it will tell you, well, something's going to happen to your data. So at least you realize what's happening in that particular situation. Okay? So again, all the nice tools of the InfoWorks ICM network are used in the SWM network. So a lot of potential modeling problems are kind of fixed before you're even able to run model, because you have to do the validation and make it be committed and get it to actually work. So that's a little bit about the report file and also the validation. So the validation tells you pretty good detail of data errors, and also it tells you what the warnings are. So this W means that it's a SWM warning. So at least you get to know what's happening there. All right, now, how do we know our model is any good? Well, classic one is to check the overall mass balance. There's a flood, how much flooding is there? And there's a lot of different ways of doing that. You can look at the nice SWM5 mass balance tables. You can look at the summary or system report and graphs for flooding and for node flooding, etc. So you can get an idea what's happening there. You can do things like really have nice comparison between the rainfall, between what's happening with the rainfall and the other systems. You can also look at the individual node errors. I like to look at those. So even if the continuity error is pretty good, you might want to look at the overall node errors and just make sure that that no single node has a larger continuity error. So you might have a situation where one node is off, but overall the system is really close. So, okay, instability of links. Again, you look at the link summary table to tell you whether the links are unstable, and you can take a look at those particular links to see if the model is stable. D over D and Q over Q. I mentioned you can use that with the SQL. You can look at on the long section plots. You can look at the max. You can look at the time series. You can look at the values over time. So it gives you an idea of an understanding maybe of how your system is working. Is it excess capacity? Is it partial flow? Is it surcharge flow? Is it flooding flow? So you look at all that, and that's all based on, as I mentioned, a combination of the IWR file, which is the summary, and the time series. Timestep issue is another classic issue where people basically don't use too big a timestep. Now, SWM does have a variable timestep, and I always recommend that you use that. However, if you make a max time step, for example, of 300 seconds or 60 seconds, and your actual average time step is 1 or 2 seconds, you're missing a lot of there's a lot of oscillations that might happen as it kind of moves from 300 or 60 down to 1 second during certain times. So it's better to have a time step that's kind of close to your average time step. And there's a nice table in the SWM5 output report file that tells you what your max, min, and average time step is, and you should try to have your max not too much bigger than your average. Okay, then how does your model compare to monitor data? Well, there's a really nice feature inside of the InfoWorks thing called Observe Predicted Graphs. You can do the same graphs with the SWM network. So as many monitor data as you have, you can then compare it to your simulation data, and it does that for depth, velocity, and flow. Modeling the right processes, that's a key thing. A common question is always, somebody turns off, for example, RDII in the process, and then they complain that they don't have RDII. So you want to make sure, the way to do that is to look at the continuity summary tables, look at the system report or summary graphs in SWM networks or in the SWM5 output to see if you do have all of the processes that you think you are. And number 8 is, again, the system graphs and tables. It's always nice. EPA did a really nice job of summarizing your model from a holistic point of view. So you can look at the overall area weighted rainfall, runoff, dry weather flow, RDII, groundwater, outflow, flooding, outfall. So you just take a look at all those. It doesn't take that long, and it gives you an idea of does my model look okay, etc. And that's an important part of the summary graphs and tables inside of SWM network, inside of ICM as well. Speeding up your model, especially nowadays with GIS, you always want to have a situation where you're not using like a 1 foot or 1 meter pipe, and you're not using the conduit lengthening. So if you use a 1 meter pipe, and you have a normal velocity, you're going to use sub 1 second time steps. It goes down to 0.001 second now. So your model might take a really long time. So a judicious use of the conduit lengthening option is really good and really speeds up your model. In fact, it can speed up your model by a factor of 10 to 25 pretty easily. And then for the dry weather, for the dynamic wave parameters, I should mention that the SWM network inside of InfoWorks ICM does not have a kinematic wave or steady state. So we decided to go with the better solution, which is dynamic wave. So you don't have to worry about things like looping, flow splitting, etc. So it makes things simple, and it makes it nicer to connect to things like 2D modeling. And calibration graphs I mentioned already, but basically it allows you to basically see if you have a pretty decent model based on some other data. And then model sensitivity, there's really neat tools inside of InfoWorks ICM GUI that allow you to have a lot of different scenarios, compare those scenarios in different model runs, so you can see the effect of a time step, iteration, convergence options, etc., to make it you have a better model. So a lot of what we did here is to allow you to basically, instead of giving you like canned tables all the time, we allow you to basically construct and save what's best for you, for your understanding of what's happening in your model, and also see the sensitivity of your various parameters. All right, good, move on.
Yeah, we've got some questions coming in, but one in particular that was a while back that kind of relates to that. But so I guess we have some how-to tutorials for InfoWorks ICM networks, and he's asking if we're planning to create any for SWM specifically. I'm not aware of much. I mean, hopefully that checklist is kind of a good resource for what to check and things like that. And a lot of the same workflows, a lot of the workflows between an ICM network and creating it, it's going to be fairly similar for a SWM network. Is there anything you know about, Bob?
Okay, well, as Ryan mentioned, I'm part of the support group, and basically our support group is worldwide. So we have a bunch of people in the UK, a bunch of people in Australia, a bunch of people in North America, mainly in the US. And one of our important tasks coming forward is we're going to have maybe I shouldn't mention this, but anyway, we're going to become more fully integrated with Autodesk. So essentially, we're going to have, by the end of March, we'll have all of these workflows and all of these, a lot more examples of how you run SWM networks using ICM tools inside of InfoWorks ICM. So end of March is our deadline for that, and so we'll have a lot of videos and a lot of blogs, etc., on the support portal about that. Hopefully that answers the question. But yeah, we realized there's a lot of new features here, and so we're trying to document everything as much as possible for that, or yeah, basically to completion. So hopefully that answered that question. Okay.
Yeah, we've got some more questions, but I'll let you keep.
One more question, and then.
Oh, sure. Yeah, how one person just asking about the differences between an ICM SWM network and an XP and the XP SWM model. My biggest thought is the engine. The engines are different. I don't know if you want to answer that more in depth.
Yeah, so basically, we have a few slides later. Part of the handout, probably won't get to it because it's running out of time here. But basically, XP SWM is a modified SWM 4 network. So that goes back to the 90s, essentially. The ICM SWM network is based on SWM 5, and it basically is upgraded every time there's a release of EPA SWM. So it's currently EPA SWM 5.1.015. So it's and that's basically last year's version. When the new version of SWM 5.2 comes out, we'll incorporate that in the SWM network of InfoWorks ICM. And the ICM network solution is very different. It's basically a 4-point pre-SWM Prisma solution. So it's basically more of a matrix solution than the node by node or a link by link solution of the SWM5. Okay. All right, let's do a few more slides and get back to the questions.
Yeah.
All right, so as I mentioned, one of the really, really nice features that I really love about InfoWorks ICM GUI is the fact that you can do anything with any of the data. So no matter, you can always right mouse click and show the data. So you get to see all of the, you can pick anything in the model you can show on a long section plot. You can show in a graph, you can do an SQL with it, you can do a theme with it, and it just shows a few examples. So the way it works is the top part, my mouse works here, the top part is the input data, and then we do have some user-defined text and numbers, and then at the bottom you have the output. So you can mix and match the input and output. So let's move along here. Okay. Also, the way we set this up, there's a lot of really good import-export features. So for example, if you have an ICM network or you have a SWM network inside of InfoWorks, you can import and export SWM5 basically painlessly. So basically you can almost take a export to a SWM5 model and then run it immediately in SWM5. And we also have some older ones, for example, a mouse, we can import mouse, import SWM4, you can also import XP SWM, and you can import info drainage, which is another one of our products that is also based on the SWM engine with some modifications. So a lot of different import, export, and I'm really happy with how basically easy it is to import and export that. So it kind of combines everything together, doing that. All right, I'll skip over this, but basically both networks solve the 1D Saint-Venant equation. I will mention that they share the 2D engine. So if you use 2D data or 2D mesh inside of InfoWorks ICM, it basically is the same mesh and the same engine that's used in the SWM network of ICM. So that at least is the same. So the 1D is very different. The 2D is exactly the same, and the data for that is the same. So the difference is obviously the connection. I won't go through this, but basically these are the differences in the Saint-Venant solution for the two programs. So you can take a look at that later if you're really interested in it. Another big difference between is that there's more computational points in ICM networks than there is in SWM networks. In SWM, there's only one flow in the middle. You get upstream and downstream. In ICM networks, you have up to 5 or more computational points. So what that means is that when you're looking at and comparing the models, when you graph a SWM network or SWM5 model result, you're looking at the middle of the pipe. When you're graphing a ICM or InfoWorks network inside of ICM, it's very hard to get that straight there. You're looking at the upstream and downstream ends and not the middle. So middle versus upstream and downstream, though you can in ICM also show the middle part. Okay. More stuff about head losses, so I'll just skip over that. You can look at this graph there. Slot, very important, especially in the newer SWM models. It has a Prisma slot or a Prisma slot, so it essentially models the same, the flow using the same equation, no matter partial pressure or surcharge flow. So it makes it a lot more stable to use a slot. You do have to use a smaller time step. And then in ICM, you have some more options with the slot, but you can take a look at that later. Let's see here. Let's see, what time is it? I think I should go to the network here. So you can take a look at this. This is a log file of ICM. There's also a sort of a log file in SWM5. You can look at things like the time step frequency, the percent not converging. The percent not converging basically usually is pumps. So normally you don't worry about that, but basically, essentially you look at a few things here to make your model the best and basically eliminate a lot of issues. So the maximum time step should not be too much bigger than the average time step. You want to make sure that the minimum time step is not too small. If it is too small, use the conduit lengthening. That really helps you to have a longer time step and make your models more stable and also essentially run a lot faster. Average iterations, if this is too high, then you would basically change the time step or change the convergence tolerance. And you have the total number of time steps, and this gives you an idea of what the timing is going on in that. Here's an example of SQL. You go over here to selection, go down to SQL and say, I want to use, I want to change the IDs. So basically it gives you a little language to do that. You can also query the output and see what's happening in the system. Just take a look at that later, but basically, as I mentioned, a lot of the input export of the input features of ICM can be used in SWM and vice versa, which is really nice to do things. Okay, let's go over to the model here. Any questions before I shift over to this part?
Yeah, we should address some. This one was back on that 12-point checklist, kind of specific to the slide, so I don't know if you want to run back to that one real quick, but just a question about in item 9, should it say lengthen instead of should it say lengthen and increase roughness instead of shorten? And I believe it was correct on the slide that once you shorten a pipe in order to have the same number of losses, you would have to increase that Mannings.
Did I say that wrong?
No, I think it's correct in the slide. But let's go back and take a look.
So number 9. Yeah, that's a mistake. It should say lengthen.
Okay. So, yep. So it is supposed to be lengthened. Sorry about that.
Yeah, that's something. Yeah, unfortunately, things that that's something I've been dealing with for 40 years. So I knew what I was talking about. Anyway, but that definitely is not correct. So you're lengthening the pipe and you're lowering the roughness so that the velocity and the flow is the same. So that's totally totally screwed up there. Okay.
So when you have a lot of oscillations in gravity networks, is there like a best place to start when diagnosing the problem in an effort to smooth out that noise?
Sure. Now there's a few options. And basically what I always suggest is the fact, the options here. Is essentially you either change the time step, and as I mentioned, one of the really key problems I think with the SWM5 solution, especially, is the fact that there's only one flow in the link. So if you have a situation where you have oscillations inside the link, and even if you don't have continuity error, one of the ways you can get rid of that oscillation is basically to basically use the ignore option for the dynamic wave, and that's under this. It's under model parameters. So you go to model parameters options, and you essentially say inertial dampening is ignore. Oh, okay. A little bit tricky here, but it's one of the things you need to get used to is I'm looking at the output here, so I can't change the data in the models. But basically, you would change ignore here, to change that to ignore. If I come over here, then I can change the value. But basically, you would use ignore. What ignore does is it takes away one of the terms of the St. Fanon equation, so you don't have the oscillation from upstream and downstream to the system. So that's one way to do that. Another way of doing that, obviously, is to change a time step, to change the convergence tolerance, or to make a number or increase the number of iterations. But especially for really big natural channels, it can be kind of hard sometimes to get rid of that. So another way is to basically perhaps break that system up into two lengths. And we have a tool now in the soon to released ICM 2023 rather, that allows you to basically automatically split pipes or links. So you can make a conduit that's unstable, perhaps make it into 2 or 3, and it'll increase stability, especially for force mains and natural channels. All right, I went too long for that one. Next question.
Just looking maybe for some modeling advice. Someone out there has a system, 2D and storm drain network that has a river as an outfall. Just looking for advice on what the best way of modeling that boundary condition would be. In the method that they're currently using is to use a head boundary, which to me sounds like the right way to do it, but there's some concern about water being sent back into the model. I mean, it sounds like that.
The head boundary, you could put a flap gate in, so that, or flap gate at the node, or a flap gate in the link, and that would prevent water from getting back in. Another common thing for the natural channel exit to the outfalls also is a normal depth, so use normal depth. But if you don't want to have flow getting into the system, you can just put a flap gate in there. I will mention that.
And I would think if there's stability issues with water kind of pouring into the model initially, you could look into using some initial conditions. I know that's in ICM networks. I'm not sure if it's in SWM networks yet.
Yeah, so for example here, where's that? Probably a very important part. A lot of times, especially if a big network, using a hot start file will basically eliminate a lot of the oscillations in the beginning of the simulation. Now it's a little bit different here. So instead of calling it hot start file, it's called a sim providing initial state and a sim providing final state, which essentially is a hot start file. But works the same way as ICM. So you basically run the model one time, remember the final state the final state, and then that becomes the initial state of the next model run. So you can do this iteratively, and allows you to do things like sort of like have quasi steady state flows into the system So for example, you would run this model, save the hot start file, and then run it again with a very small very small simulation length, and then that'll give you quasi steady state. So hot start file, or what we call in InfoWorks, ICM, and SWM networks, is a simulation final and initial state. Same thing as hot start file though. Okay.
One question that I kind of overlooked a little bit before, but is there some sort of like rule of thumb that you would recommend that, setting your time step versus the, say, smallest pipe length? I'm guessing this kind of revolves around the Courant condition and satisfying that, but what would be your recommendation, Bob?
Well, there's two issues. First of all, if you have a very small pipe, the model actually works, or SWM networks tend to work better at running the CFL condition. If you have a very small pipe, for example, like a 1 foot pipe, that means you're running a very small time step. So then it really kind of messes up with the other longer pipes. So you're using a really tiny time step, but the longer pipes need a CFL time step of a bigger time step, basically. So then you have a situation where your time steps are too different, or required are too different, and the restriction is, and it's actually the same restriction ICM, the smallest pipe controls the whole model. So by using the conduit lengthening and making it longer with less roughness allows you to have a longer time step. It makes the time steps used based on the CFL condition more uniform throughout the entire network. So you get a better model that way. Okay, hopefully that
And kind
answered
of,
that.
yeah, I think so. And kind of along the same lines, you mentioned the summary table will provide the maximum average and minimum time step that your swim model is running. Is there a ratio between those three outputs that would signify you're running at the
Yeah,
best possible
I have
kind
a
of time
blog somewhere that I'd say something like 5. So for example, if the average time step is 2 seconds, then don't use something greater than 10 seconds as a time step. If it's 1 second, then don't use something greater than 5 seconds.
I guess what I'm saying is there some kind of um, if your average time second is 2, would you say that a maximum time step of a ratio of that, like 6 or something, that would be a ratio of 3 between those? Does that make sense at
Yeah,
all?
if it was 2, I would always go with 5 or 10. So I wouldn't go with 6. So I would kind of round up or round down.
Oh, so it would be like a 5
Yeah.
ratio of 5. Gotcha. Um, Got a couple more. Just a comment about the checklist being a fantastic resource, and that if we have any more resources that go through um, those things in more detail, or if we have any online resources for model verification.
Yeah, we do. Well, we have the portal. We also have online help file. So there's online help file for both the InfoWorks and the SWM network here. And of course, Lou Rosman and EPA have really fantastic documentation for SWM. Really get into the theory of LIDs, the hydraulics, and that. So you can always look at that from the EPA website. And as I mentioned, we're kind of consolidating here. So we are writing a lot of new stuff for the end of March kind of launch into official Autodesk life here. But but that's something that we realize and it will be available. Okay.
Gotcha. And just one about the SQL queries and routines. I know I don't, but I have one for ICM. I'm guessing you maybe have a library of SQL queries for swim networks. Some of the ones I have for ICM should work, but if the field names are different, it might be.
Yeah. One of the nice things about the SQL stats, let's go to SQL.
And I guess would you be willing to share that library?
Yeah, it's the in the support portal under the GitHub. So we actually have a GitHub. So here's an example. One of the nice things about this is you don't have to do this every single time. So what you do is you basically do it one time. You make a SQL query for capacity. Show me the max capacity of all the pipes greater than 0.75, and you don't have to do that for any new model. So as a consequence, when you have a run, let's get down here and get a run here. And then I can just click on the SQL capacity, run it, and it'll show me all the pipes kind of in red that have that meet that. So all you need to do is really simple is you make the SQL little program, save it over here, do the same thing for like Q over Q full, and you basically just operate it on a drag and drop network. The same thing with the stats templates. So for example, I have a stats templates for, here we go, surcharged. So you make that for a particular network and then you don't have to make it again. So you just save it. So everything you're doing, so you really customize, you're basically making value added sort of like your idea of what's important for this particular network. Hopefully that answered that question.
Yeah, and we had some comments and questions about what that website is. I did drop it in the chat. It's simply github.com/Innovize. It's also very easy to find if you just do a Google search for Innovize GitHub. So hopefully that kind of covers that. Just trying to look through different questions. We do have a question about, is Innovize contemplating to retire InfoSwim soon, which I feel like is often the elephant in the room for some of these water talks. So currently we're not in the process of developing an InfoSwim Pro or an InfoSwim version that would run on top of ArcGIS Pro. And we've been loosely tying our support of InfoSwim to when Esri will retire ArcMap, which is what InfoSwim runs on top of. Currently, that's set at 2026. We've been told by Esri that they're not developing any more versions of ArcMap, so that's generally the timeline we're looking at for that.
Yeah, we'll mention that. Probably won't buy too far there, but basically it's import a model group. So when you import a model group, it's a lot more than just importing a file. So you're importing, for example, from InfoSwim, you're importing all the patterns, all the time series, all of the rainfall, in addition to the nodes, the links, etc. And you can do this multiple times, so you can basically then make scenarios, not totally really fast, but you can make the scenarios inside of the SWIM network in InfoWorks ICM similar to or the same as the InfoSwim. And I've used that quite often. So that's sort of our pathway for InfoSwim, is to migrate to here. But as Ryan says, we're going to support InfoSwim as long as Esri has support for ArcMap.
And we got a question here about wastewater collection systems and modeling one that has a lot of pumps, and it sounds like subsequently force mains. And just curious about your recommendation on which program, which solver, which parameters should you use in that situation. I know there's differences between the Priestman slot method and the Xtran, and advantages and disadvantages to either one of those. I don't know if you want to.
Yeah, what I would recommend is the slot method, because it's more stable. However, there's the issues that you might have with the slot method is if you have, and a lot of people do this, if they put in too much detail at the pump. So for example, if you have a pump going to a node and you have an offset at that node, that might be a problem with the slot, because you're basically changing the area. Another kind of feature of SWIM 5 that people don't really realize is the fact there's a link node model. So for example, if you're modeling a force main that goes into a node that has an offset between the pipe and the node, sometimes the area of that node switches by a factor of 2. So instead of using the length of the pipe, it uses basically nothing for that pipe. So that can cause an oscillation. In that case, the Xtran solution is better. Xtran surcharge solution is better. One of the biggest things I see with the force mains, though, is that people put in really long force mains. You always see, like, somebody sends a model, it's like 10,000 feet long, 15,000 feet long. When you do that, make sure that you break that force main up into smaller bits. And it doesn't have to be like really tiny bits. You just take, for example, take a 10,000 foot long pipe and make it into 2 or 3 segments. And that really helps the behavior of the force main, especially if you have a pump that turns on and off very fast or very often. It gives that enough time for the pump to react to the various parts of the force main. Okay.
Yeah, and just one more question about importing a SWIM network into an ICM network and running it. How's the result similar or different between the two? I'll start out with my experience with that. It's fairly similar. It's not exactly the same. There's also some different. the two different networks report differently. For instance, ICM has an upstream and downstream flow and velocity, whereas SWM just reports one flow for the entire pipe. Things like that. I don't know if you want to talk more on that.
Yeah, the big difference obviously is the linked node part. ICM basically calculates the head at the nodes and doesn't use the node area. So that's one of the big reasons for instability. And the two biggest reasons for instability in SWM really is the linked node part and the fact that it only has one flow inside of a link. So you can have like internal, and it does do 3 computational points. So basically you can have oscillation from the upstream and downstream of the link. ICM doesn't have that because ICM has 5 or more computational points in the link. So that makes it a lot smoother. Okay.
And to add on to that, just because they're different doesn't mean one's more accurate or a better simulation than the other. So just to throw that out there. That's it. I know you had some statistical templates and things that seemed interesting you were going to share, Bob. Is that right?
Yeah, well,
Or you do you not think you have enough time?
well, what I probably should do is okay. I also do some of this stuff on LinkedIn. So I'll put some stuff on LinkedIn and also in the portal. Basically, how you do the flow survey stuff, how you do the statistical stuff. So basically, the key thing about the statistics and the worst case and the SQL is it gives you different ways of interacting with the model results and the theme. So for example, if you were to do a SQL, let's do an SQL here. I think I got the wrong here. Okay. Once you do the SQL, you can then open the selection in grid view and do a theme. So that's a lot of, it's a fantastic interface for like interoperability. So basically you're looking at the same data, but you look at it in so many different ways. It gives you a better understanding of your network. Okay. All right, so you look
And then, sorry, I thought you were done. Go ahead,
sorry,
keep going.
I'm done. Go ahead.
Oh, just about the checklist being pasted in the chat. I thought in the handouts all those slides were there. Yeah. So all the slides are in the handouts tab. So you can grab that and be able to get that checklist from there.
No, I need to change that one bullet 9, I guess is a bad mistake there.
With that, that's pretty much all the questions we have, and we are at the top of the hour. So I guess if there's nothing really else out there, we can call it. Thanks, Bob. Really appreciate all the feedback and hope everyone learned a lot. So thanks, and we'll see you next time.
Okay, thank you, Ryan, and thank you, attendees. Appreciate it.